Welcome back to Wickerson Studios. My name is Michael Wickerson. I'm going through the Python one-liners book, and I am into chapter 4 of the Machine Learning 10 Examples. This is the 5th one, the one I've been looking forward to because it's wildly popular, which is a neural network analysis. And I've produced the underside of a roof, which is a pretty interesting top as well as sealed breps. Pretty interesting to consider this for fabrication and the patterns within it. I'll zoom out a little bit to show you kind of what's going on here. It's basically a geometry that's driven by some very interesting data, and I took the base data or the script out of the book, but we're literally dealing with one-liner scripts in neural network scripts in Python within Grasshopper. And of course, I'm making my arrays parametric, so you can have, but I've put in up to 9 inputs. Can drive this, 9 samples can drive this with 6 different inputs on each, 5 of which are data going in, and the last one is the output, which is data coming out. It runs fairly simple, and because I chose to do my old Grasshopper techniques of node scripting, I'm going to slowly push it into Python, but I don't see any point in pushing the visualization of node scripting into full-out Python scripting until you become a mastermind of that. So once again, it's parametric as well. It produces a series of data, the first item in each list, but since there's one item in each list, I just thought I'd choose, the way I amped it up a bit was I didn't do list items, which I did in my example, and chose to use all of the values in a jittered form. So as you take this through a actual slider, and it does slow down a little bit, 4.3 seconds to process this script. It's pretty nice. You have your inputs, and then you have your sample inputs. And my sample inputs are being generated by all of these values, again, coming out of a range of these numbers. So it does make sense to me. It's how I script. And then I'm left with some data. That's it, just some numbers. And those numbers are very interesting. They're out of order. And of course, they then drive on the geometry. And if you know anything from my past videos and what I like building geometrically is I like the quad sphere. So what I did is I'm just trying to close this one out. It's running a little bit. Oh, please don't crash on me. Sometimes it's just angry with the simplest things of just trying to close it. I'm going to need a bigger computer. I'm going to need a little more support when it comes to computational design. I shouldn't have my turntable on. That's not helping anything. But a very nice little script. I'll pop it in here. I'll go to all views. You can see the top of my file. You can see the side of that building, and I'll just bring it up to a nice caterpillar kind of shape. You can see the end of it, how it plays off of that as well. And I'll probably waste my time. Throw a little turntable there just for fun. Oh, may as well throw them all in the turntable since that's the way you can do it. I kind of like that it chooses one or the other. Leaving the turntable, I'm still very playful. Basically, this data is going to drive a quad sphere, and I probably need to just show you the basics of that. We'll zoom back out a bit. We'll turn this into shaded. We'll take our item, which is in 2 seconds. I have these diameter ribs, which is fairly nice that I can actually play off of the surface, and I can actually play off of the ribs underneath. The lines have actually become a piping, and the rest could be kind of a canopy. I really am getting into this, and of course the geometry from the top is pretty interesting. But this is probably sculptural, probably a bit architectural, and certainly deals with data science and machine learning on the most basic level. One-liner scripts, which are amazing geometries, are what you can produce. And I just love what's happening here. Anyway, I could break it down to what's happening. It's not that exciting. It's basic scripts that I use to write in Grasshopper. But let's take these two forms. Let's put those to visibility off, and let's go to everything and look at our quad sphere. And there's what I drove the geometry by. That quad sphere, I don't bring these numbers in until I move the motion, and I've moved it off in a motion relative to these points in the x direction, throwing it through a simple polar array. Which is fairly simple, but I rein the array in by a count, and the angle is dictated in degrees by those actual numbers. So if you want to change your data, you're going to change that shape. Maybe I can show an example of that. I'm just going to save beforehand, because as I start to dig into this a little bit, my mouse is getting old, my computer's too small, my computer likes to crash out all the time. I'm going to take this number slider, which is the seed, and it's also the, what else is it? It's also the radius of the circle. So I don't want to make it too small, but I'm just going to seed it down into 9 and turn it back on. So the radius got a little smaller, but now I just jigged it into a whole bunch of different shapes. And what I'll do is I'll pull that back on. Sorry. We'll take a look at what was there. It's not running anything in the solver right now, so we'll hang on. There it is. And we'll just disengage that, and we'll see how this runs in a few seconds and see what geometry we end up getting compared to the other one. I was hoping to snap it right in and not have it disappear like that, but that's just what happened. And now if it runs through all of its data, you'll see it generates another series of tops. Not too changed, but once again, you've got your quad sphere, you've got your move, and you've got your polar array, which probably did a little bit of shifting. It was very subtle for the 9, so it wasn't that drastic. Maybe what we can do is go into here to the edit and bring that down to a 5, and that'll have a different seed, and that could that might be able to do something a little more jazzy. But this is all post script working in neural networks, working in the ghPython remote node. I'm pretty excited about that. It takes a little bit of time, and then let's go back into it and see what happened. We've got our circle, we've got our lines, and then we pulled it out into its polar array, so it's a little changed. It's a little difference in size, and then I can walk it through a pipe on the edges, and the surface I can do an evaluate surface, and I can do that from any point if I wanted, but I like the MD slider. And then I just do a vector loft in the sense of 1 thickness, which isn't very thick at all. You don't even need the amplitude, but I like that. And there's a totally different pattern that's occurred underneath. And if we bake this one, I'll bake this one into 1 layer on the default, and I'll bake this one. It just takes a little bit of time. I'll bake this one into another layer on the default. Now you can see that one coming together, and what I can do is give that a second and go through all the lines. There's the red. Okay, so that's nice, and let's just put it back so we can see every shape. Pull that one back up. Oh, I had it on rotate, so it's actually behaving in some pretty interesting ways. I'll just jump over here, and I can start to see the effects of this. Let me just pull that one down and rotate it up. That one is there, and what I'll do is I will hide that one. Let me grab that group, and we'll swap it out for the other one that was there. And I think we'll have to swap the other one as well. Oh, we just brought in a whole bunch of geometry from before. I apologize. I kind of work off the same file every time. Well, you can see the 2 different ones that are there. One's lofted above, one's lofted below. And I think I'll just delete that one. I don't need it anymore. And you've got 2 here, 2 surfaces, both driven by the same algorithm, but just plain changing with the data that is that's coming out. So just changing and shifting. Pretty nice complexities. They're pretty fast running. What's nice is this is driven by obviously neural networks. It's driven by a 1 line of code. Obviously, I brought in more that I've been using in learning the system, but I'm using the neural network at this point, and I am making things parametric. So if you're interested and you would like a master file of this, this is the one I'm compiling. I'm halfway through for the intermediate advanced, and then I'll be going on to the advanced. And this is literally no joke. This one I'm going to group, and now I'm going to just break down my code a little bit. Let me close it because it always takes just a little bit just to decide to close. That's why I know I have a lot going on. And with any luck, it'll close up. There we go. And then I'm going to go into here with number 5 neural, and I'll walk through talking about this code and give a little more information on it, because that's just nicer to do, so it's actually a little more user-friendly. Just moving things around in here is starting to slow down. I think I'm going to have to do a separate file. Pushing Grasshopper on my computer to pretty much my limit. But otherwise, I hope you enjoy it. I will keep making geometries with a sense of data driving neural networks. This was the one I was excited about, and I think I am going to create some very interesting forms. And I know this is happening around the world in different pockets, I'm happy it's happening out of Wickerson Studios. And for somebody who's done Foundry for 20, 30 years and only took on computational interest in late 2018, I think I'm making some pretty good leaps and bounds. Thanks again for watching.